Let's talk about chemical bonds, formulas, and names. What we're talking about is sticking atoms together to form compounds and talking about them, that is, a nomenclature. Our tasks are the following. We must develop our notion of how atoms stick together to form molecules and aggregates of atoms and ions. We need to name acids, bases, oxides, hydrides, salts. In other words, we need to understand how to talk about the nouns of chemistry. And we need to use the periodic table to help us write chemical formulas, as well as for ionic and molecular substances. We're not going to learn all of that in this particular talk, but we'll learn a lot of it. First of all, distinguish between elements and compounds. Elements are simple substances. You can't break them down without changing their atoms. The compounds are substances made of two or more elements, so they're made of more than one kind of atom, and they are also made in definite composition. We can break them into the constituent elements, but only with a chemical change. There are noble gases that are monatomic, that is, one-atom gases like neon, helium, argon. And remember that the elements, although are all of the same kind, they can assume different forms. Diatomic gases are elements that come in packages of two. They need not be gases, but many of them are. So chlorine looks green because it absorbs in the red part of the spectrum. The diatomic elements are solids, liquids, and gases that come in packages of two. Hydrogen, H2, nitrogen, N2, oxygen, O2, fluorine, F2, chlorine, Cl2, bromine, Br2, and iodine, I2. Where are they? Well, if you look at the periodic table, it's pretty easy. I've outlined them in red. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Now, the ones below that are also diatomic, but they're radioactive and we don't use them in the chemistry lab. The halogens are indicated as X2. Again, these are the elements, not compounds of the elements. And you'll notice that the ones over here form a 7. That reminds us that there are 7 of these common elements, and that means hydrogen is part of that. Now, metals are networks of atoms in solid masses. They are shiny and conductive of electricity. Nonmetals tend to be larger molecules, or they are clumps of atoms. So graphite carbon and diamond carbon are two allotropes of carbon. Sulfur, in one of its forms, comes in actually a cycle of 8 atoms, and phosphorus comes in a package of 4. Let's go to compounds now. Compounds are composed of individual neutral molecules, are called molecular compounds. And these are held together by sharing pairs of electrons. Any compound that forms a true discrete molecule is called a molecular compound. So water is one, methane, carbon dioxide, and ammonia. You can actually talk about a molecule of carbon dioxide. Here are representations of ammonia, water, methane, and carbon dioxide. The discrete packages are called molecules. Here are some others you may have worked with, like polyvinyl alcohol, paradichlorobenzene, mothballs, and sucrose. Compounds tend to form liquids and solids with weak attractions between molecules, and therefore relatively low boiling and melting points. Water actually has a fairly strong attraction between molecules, and so it has a melting point of 0 degrees and a boiling point of 100 degrees. Many molecular compounds have much lower melting and boiling points. Now, when an atom gains or loses electrons, it gets a charge. Ionic compounds, then, are different from molecular compounds. They have relatively high melting and boiling points. So, for instance, if you did the experiment where you melted molecular compounds like paradichlorobenzene, you noticed that they melted very, very fast and maybe even boiled on a hot plate, whereas sodium chloride just, kind of looked at you and said, "Do you expect me to do something?" Sodium chloride melts at 1074 Kelvin. So the attraction between ionic particles in ionic compounds must be very strong, and it is. So, how do ionic compounds form? How do we write their formulas? Well, metals react with nonmetals to form ionic compounds. Elements on the left react with elements on the right. Metallic atoms will lose just enough electrons to look like the next smallest noble gas. That's a low energy state for them. So sodium would lose 1. It's in the first column. Calcium loses 2. Nonmetal atoms gain just enough electrons to look like the next highest noble gas. So bromine gains 1, sulfur gains 2. Now, how do you figure the charges? Well, if you have a periodic table, it's fairly easy. The charge on the metal in positives is the number of electrons it's lost to become low energy stable. So sodium in the first column loses 1, therefore its ion is Na+. Strontium loses 2, it's in the second column, so it forms the Sr2+ ion. It has a charge of +2. On nonmetals, the charge in negatives is the number of electrons it's picked up to get low energy stable, like a noble gas. Fluorine gains 1, so it forms the fluoride ion F-. It's gained 1 negative charge. Sulfur gains 2, so it forms the S2- ion. It has 2 extra electrons. So, turn the projector off, turn off your computer for a moment, or just pause, and find how many electrons each of these gains or loses to look like a noble gas. Here are your answers. Lithium loses 1, selenium gains 2, and so forth. Now, what's the formula for an ion using only a periodic table? It's pretty simple. Look at the periodic table and determine how many electrons the metal will lose or the nonmetal will gain to look like a noble gas. The charge is determined by that number of electrons gained or lost. So sodium loses 1 electron. The electron is negatively charged, and so it acquires what kind of charge? Yes, I'm positive, and so is it, +1. And look at the periodic table again and try chlorine. This gains electrons. It gains 1 electron, that's negatively charged, so it has a Cl- ion. That's the ion of chlorine. Now, you can look at this and stop the video and determine what the most stable ion is of these particular metals and nonmetals. Here's your answers. The oxide, nitride, rubidium, barium, aluminum, and chloride ions. Notice again, you can get that right from their position on the periodic table. Now, how do you name binary compounds? Well, binary means it's made of 2 elements. So sodium chloride, NaCl. We always name the metal first without a change. So we don't say sodiide, we just say sodium. The nonmetal is named second, and since it's a binary compound, it ends in IDE. Therefore, barium in the fluorine forms a compound called barium fluoride. And remember to spell it with the U before the O. K2O is potassium oxide. In the name, in ionic compounds, we ignore the number of atoms, and we also ignore the charge. So, let's name these compounds. Please note, ionic, ionic, mostly ionic, 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 mostly ionic. This is a molecular compound. We call this hydrogen bromide. If it was H2Br, it would be called dihydrogen bromide, but it's not. It doesn't have H2. Now, how do we determine the molar ratios in the compounds? Not very hard. So the formula for potassium sulfide, K and S. Potassium loses an electron to become K+, sulfur gains 2 electrons, becomes S2-. So we need 2 potassiums for every sulfur to keep it electrically neutral. The formula then is K2S. That means there's 2 potassiums and 1 sulfur. Understand the 1 on the sulfur. We don't like to draw ones. Here's another. Barium oxide. Elements are barium and oxygen. Barium loses 2 electrons, Ba2+. Oxygen gains 2 electrons, O2-. The charges are the same, but opposite in sign. Barium oxide is electrically neutral, so you just need a 1-to-1 ratio. And the formula is BaO, 1 barium, 1 oxygen. Now there's an old shortcut we call the crisscross rule. If we use the absolute values of the ionic charge, we can put the metal charge down here and the nonmetal charge down here after changing the sign. And so we have NaCl, which of course we don't write the ones. So let's look at potassium sulfide. We already know the answer. Again, we crisscross using absolute values of the charges. Potassium +1, sulfur -2. We crisscross and get K2S1 or K2S. Now, using the crisscross rule or your periodic table, whichever is more convenient, why don't you write the chemical formula and name for these compounds, and then check your answers. There's your compound formula, and here are your names. So what you've learned here, the difference between ionic and molecular compounds. Ionic are attracted by their charge, generally a metal and a nonmetal. Molecular compounds are closer together on the periodic table, and they share their electrons. The sign and value of charges on ions, both metal and nonmetal, which is a review of something you probably already know, and how to name an ion made from only one atom. The metals are just named as they are. The nonmetals, you change the ending to IDE. And how many electrons you gain or lose to create an ion. And then finally, how to write formulas of compounds, especially using the crisscross rule.